In this exercise, we're given a type 2 surface integral to calculate. We're given the vector field f as follows, and let me call the components p, q, and r. And S is the surface of the body. It's given by four different surfaces. The two planes x equals 0 and x equals 3, and then z. Well, this is a parabolic cylinder. You know what? I'll try and sketch this at least in 2 dimensions. If I look at these two equations, the last two in the yz plane, I've got two functions. Z equals 4 minus y squared is an inverted parabola, and if I look at where it cuts the axes, when y is 0, then z is 4, and when z is 0, then I get y squared is 4, so y is plus or minus 2. And so the parabola looks like this, something like this. But because it's bounded below by z equals 0, it doesn't continue on. It closes here. So this is what it looks like in the zy plane. In fact, it would be the same intersection in any plane where x is constant. This happens to be where x is 0. X goes from here out. It goes above, out of the paper, so to speak, and so it has a thickness of 3, but it looks the same everywhere. Perhaps I'll show you what it might look like. Here's what a parabolic cylinder looks like. This one seems to be made of wood from a different angle, but if we rotated this, and this would be maybe x equals 0, this would be x equals 3, the x would be upwards, the floor would be the zy plane, and it would give an impression like this. Let's also draw one more from the side, from the xy plane. So now I'm looking from above, from the z direction, and this just looks like a line from -2 to 2. But I know that x goes from 0 to 3, so instead of coming outwards or upwards, I just go like this, 3 units. So I'll get something like this, not quite straight. And let me tell you right away that we're going to do it with the divergence theorem, because this surface is made up of 4 separate surfaces. I have the parabolic cylinder. I have this rectangle, which would be this base here, and I have 2 of these that look like this, one at x is 0 and one at x equals 3, and it's going to be messy to do it over the surface. So with the divergence theorem, you know what, let me move this to the side. Let's just write the divergence theorem that we're going to use is that this double integral over S of f dot n ds will equal the triple integral